In this video I'm going to show you how we can code up the RK4 method in MATLAB. Now in a previous video I showed you how to code up the Euler method, and I've got the code here. So this sets up a simple initial value problem, and it uses the Euler method to solve it. Okay, so if you scroll down you can see that here we have our solve IVP function, which steps through the different steps for the solution, and it invokes the Euler method. So what I'm going to do is to use the RK4 function. So I'm going to add a function below the code. So remember, in MATLAB all the functions have to come at the bottom of the script, and this is going to have the same inputs as the Euler method, but the difference is here that we're going to have to calculate our stage values. Okay, so you can see we got our stage values. Now for these particular values, check out the RK4 method. Okay, so we have K1 and K2, that's going to be Y plus a half times H times K1, and as I mentioned, these values here, the coefficients, these can be found by looking it up in the lecture notes. So K3 is similar to K2, and we have K4, which is T plus H, Y plus H times K3. K3. So these are the stage values, and then we can calculate the new, or the solution at the new step, which is the current solution, plus H over 6 times K1 plus 2 times K2 plus 2 times K3 plus K4. Okay, so that's our RK4 method coded up, and to change this code to use the RK4 method, we just change this name here. So at RK4, that passes this function into our solve IVP function. So I'm going to run that. Okay, and we can see we've got a solution. Okay, so here we have the table of solutions, and we also have a plot. And the plot looks fairly similar to the one which obtained using the Euler method, but we can. The beauty of doing the code like this is we can actually compare them. So I could solve for the RK4 method. I'm going to just change those to RK4, and I can also copy and paste and solve for the Euler method, just to compare the solutions. Okay, so just change that to Y Euler and Y RK4. I should really add another column to my table. So add another column, and so I'm outputting Y Euler, and so we should really change the column headings, and that's going to be RK4. Okay, if we run that, I'll add a new line there just so it looks better. Okay, and I can just tidy up the table somewhat. I mean, this is all cosmetic, it's not really necessary, but you know. Okay, so those are our Euler method solutions in YRK4. Now we'd expect the RK4 method to be much more accurate, but in this case we can calculate the exact solution, so we can just see how accurate. Now the exact solution, define the exact solution, so I'm going to use an inline function. So inline functions are the function name equals at symbol the inputs, so we only need the input t, and the exact solution is e to the t squared divided by 2. Note that I used dot before the power. This is because so it'll allow me to put in t as an array of values as well. So once I define the exact solution, okay, I can have the exact solution here. So exact for tn. Okay, and I'm going to just change that to 9.6f. Okay, and that's the exact solution. So I should really add in a column heading and sort out the table as well. Okay, so here we have the exact solution. Now if we compare across, you can see with the RK4 method's fairly accurate. I mean, it's not until sort of this step here where we're starting to lose 6 decimal place accuracy. But the Euler method, that's not very good at all. As you can see, we've got quite a difference between the solution and the method. This can be seen more clearly if we actually plot the exact solution. So to do this, I'm going to create an array of lots of values between t-span 1 and t-span 2. So remember that t-span are our domains of the t-domain. Okay, so let's say 200, just some large value. And I'm going to plot t-exact against the exact solution. I'm going to plot it as a black line. Okay, and yeah, give it a line width of 2. Okay, doing multiple plots in MATLAB, we have to use hold on and hold off. So okay, you do one plot, hold on, do all the other plots, and then hold off. So I'm also going to plot the Euler method. Okay, so going to plot the Euler method and using blue, and the RK4 using red. Just change that marker face color. If we run that, see what happens. Yeah, I should really put a legend in as well. So let's add a legend. So we've got the exact solution. We got RK, yeah, sort of Euler first, and then RK4. Okay, and if we want to, at the moment the legend is actually obscuring part of the plot, so I think we can, if we do change the location, let's say we've got one at the top left, so that'll be northwest. There we go. Okay, so here we can see the blue line is our Euler method solution, the red line is our RK4 method solution, and the black line is the exact solution.